So we have a division type question for a rational function. The first thing we want to do is, when I look at this, I actually see 4 quadratics. Okay, so there's a bit of intuition in that. To see that really quickly, we have a polynomial to the power of 2, another one, and another one. So what will be helpful here is if I can actually factor all of these and put them into little sets of brackets. That way they're all multiplied together instead of being added and subtracted terms, and then I can probably do a lot more with them. So what I'm going to do is I'm going to individually deal with each of these. So I'm going to deal with this first one here. I'm going to do a little factoring on the side here. So 6y squared minus 5y plus 1. Okay. I want to do some factoring of this. So I'm going to do this relatively quickly. But we do have to remember our factoring rules. We're looking for 2 numbers that multiply to a times c, which in this case is 6 times 1, which is 6. And those same 2 numbers are going to equal our b value, which in this case is negative 5. And if I do negative 6 and positive 1, that works out. Positive 1. What that'll give me is 6y squared. And then in the middle, I get negative 6y plus y plus 1. We've decomposed that middle term, and then we do some factoring by grouping. Is that familiar to do, the factoring by grouping?
Yeah.
So here I can take out 6y out of both of these. So we'll get 6y, and that will give us just y inside and negative 1. And on the other one, I'm actually going to just take out... did I make a mistake there? Is that a negative? Negative 6y. Oh, sorry. Let's take out...
What? I think that's right, no?
I don't think it is. Because I'm not going to get the same y. I'm going to end up with y plus 1. What have I done wrong? Unless I've written the question incorrectly. Negative 6. Oh, what am I doing? No, this is good that I went through this. I was very arrogant in my answer. That's wrong. That's the wrong answer, actually, for the factoring. There is another solution that works. So this is good. I got here and I said, hey, I can't factor that. My little check. Those aren't the right factors. Even though they looked like they work, I made a mistake. Negative 6 times positive 1 does not give me positive 6. So that doesn't work there. And in fact, there's another pairing that works of factors. And the other pairing is negative 2 and negative 3. Yeah. So that was my error. Okay. Speed through it a little more, since I'm even slower than I thought I was going to be. Well, factor by grouping here, I can divide both of these by 2y. So 2y is the common value, and I'll get 3y minus 1. And over here, if I just factor out negative 1 from both of these, I will get positive 3y minus 1. 2 sets of brackets that are the same, and we get 2y minus 1 times 3y minus 1. So there's a pair. I'm going to come back over. I'm going to write it in here so we don't lose what we're doing. Okay. We get 2y minus 1 and 3y minus 1. So I did that value, the numerator of that one first, because when we deal with division, when I factor this, I'm going to have to get a set of restrictions because it's a denominator. When I factor this, I'm going to have to get a set of restrictions. And because this is division, we're essentially going to turn it to a multiplication question where this numerator is going to become a denominator, and then I'll have to get the restrictions. So I actually have to get the restrictions for all 3 of these parts, okay, just for this to work properly. So I'll work on the next one here. Did that on red. Let's do this one in blue. Okay, we got blue here. I'm going to move it to the side and do some factoring. 12, negative 5, and negative 2, let's say. So 12y squared, negative 5y, and negative 2. We got 2 numbers that equal negative 24. Those same 2 numbers got to add to negative 5. 2 numbers that multiplied negative 24 and add to 5. Add to 5. That seems like a mess. Am I missing any? 1, 2 is 12. 3 is 8. There it is. 3 is 8. There we go. -8 and +3. Those will work. 12y squared minus 8y plus 3y minus 2. We common factor, and I can take out 4y out of both of those. That will leave us with 4y. This will become 3y minus 2. And then the other one, I don't got to factor anything. But what's challenging is that there's an invisible 1 there. Let me just jumped up on the page. There's a lot of factoring. This one takes a while. So when we go to write out the factors, I get 4y, and what's here? Technically, there's a 1, so I would say plus 1. And then 3y minus 2. Before I go and rewrite that, I'm already here. I might as well state my restrictions. Remember, this part also cannot be equal to 0. That's what's important. So I'm going to split this. 4y plus 1 cannot equal 0, and 3y minus 2 cannot equal 0. So that's going to give me y cannot be -1 over 4. Oh, I wrote that wrong. Okay. Cannot be 1 over 4. And y cannot be +2 over 3. So we've got to keep those in mind as a pair of restrictions. We'll jump back up, zoom out a little. We'll write our newfound denominator in here, 4y plus 1, 3y minus 2. Okay, so that's one of the pairings. And I still got 2 more to do. There's quite a bit to this question.
Yeah.
We'll do this one in green. This one is 3y squared minus 4y plus 1. So we'll jump over here. We'll zoom in. Same concept. I'll try to go through the factoring a bit quicker. Zoom out a bit. We need 2 numbers that multiply 3 and add to -4. That's going to be -1 and -3, I believe. So we'll get 3y squared minus 3y minus y plus 1. This gives me 3y as a factor. Gives me y minus 1, and that becomes -y. Oh, actually, I'm going to factor out -1, and I'll get y minus 1. That gives us 3y minus 1 and y minus 1. Like we said before, because we're already here, we'll find those restrictions really quickly. 3y minus 1 cannot be 0, and y minus 1 cannot be 0. So that gives us that y. There we go, sorry. Y cannot be 1 over 3. All I did was move the 1 to the other side, so it became positive, and then I divided by 3. And same, y cannot be +1. We can now move over. What do we got? 3y minus 1 and y minus 1. 3y minus 1 and y minus 1. Whew. Okay. Last set of factoring. I don't think I have a color orange for right now. I don't. We'll do this one in black. 4, 3, and -1 over this corner here. 4, 3, and -1. I need -4 and +3. That's going to be negative. Why can't I think of this? 2 numbers that add to 3 and multiply to 4.
It has to be -3 and 1.
-3 and 1 won't get us to 4 when we multiply.
Oh, right. I mean,
+4 and -1.
Yeah, that's I mixed up 4 and 3.
There we go. There we go. So many of starting to rot our brain. Okay, so +4, so +4y minus y minus 1. Common factor. 4y comes out. We're left with y plus 1. And common factor negative, we get y plus 1. gives us 4y minus 1 times y plus 1. Since we're already here, let's find some restrictions. We got 4y minus 1 cannot equal 0. Y plus 1 cannot equal 0. Y cannot equal 1 over 4. Y cannot equal negative 1. Let's go all the way back. 4y minus 1, y plus 1. 4y minus 1, y plus 1. Okay, finally factored a whole bunch of stuff. But I have division of fractions. So actually, to make this easier, we're just going to invert the second fraction or the second rational. We'll flip them over and make it a multiplication question. So when it's multiplication, we get 2y minus 1, 3y minus 1, okay, over. So the first value doesn't change. This rational, everything's the same here. And then when we multiply it, we flip this. 4y minus 1, y plus 1, divided by 3y minus 1. So we've taken the numerator and brought it down. And we took the denominator and brought it above. We talked about this a little before. Because it's multiplication, we can just write this as one large fraction. All the numerators go together. And because of our commutative property, I think it's commutative property. It might be associative. We can just multiply in any order that we like. We'll put them all together here. And what's nice, we already got all of our restrictions. We did that very tedious work after factoring. I wonder if I made a mistake with that 3y over 2. Oh, no, I didn't. I can see you can cancel out here. Okay, finally, got a whole bunch of stuff. We're just going to look for common sets of brackets. So there's a 3y minus 1 and a 3y minus 1. So that disappears. That's it. All of that work, unless I made an error in the factoring, which is possible. It is possible I did.
I can check the answer.
Yeah, but it looks like from what we got, we just have 2y minus 1, 4y minus 1 times y plus 1. I mean, you could expand after. I don't think anyone would ask you to do that. You've done enough work at this point. But I'll keep this. This is a y minus 1, so that doesn't work. This is a 4y plus 1. And this is a 3y minus 2. It doesn't look like anything else. It's possible I got an operator wrong. So if we look closely, I might want to double check these two brackets and these two brackets. Just because if the operator's wrong, then I could have canceled one of them out because one's a plus, one's a minus. But because they're opposite, if we factor correctly, then there's nowhere else we can go in that question. So a heck of a lot of work.
You're good. The answer's right.
Yeah. So a heck of a lot of work for getting rid of a very small little bracket there. Okay?
Holy crap.